Hello everybody and welcome to day 21 of Advent of Code 2023. I will show you the today's problem, which is a step counter. So our goal is to start in this position marked by S and then walk through a maze which has some garden plots which are walkable and rocks which are not. And our goal is to calculate which locations can we reach in exactly 64 steps. So we are stepping through the maze and trying to see how far we can go through this walking. And one interesting thing that we can notice is that whenever we make a step, we can if we here we have this is first step, then second step. So you can notice that every even number of steps means that if you are requested to make an even number of steps, you will always never be able to reach the odd locations, because you will always go forward and back 2 steps, basically, not 1 step. So this way you can notice that you can fill only the even locations and not the odd ones. So based on that, I think I will try to implement this solution. So right. Okay, so we can try the simple example first and use that to calculate how many locations can be reached by 6 steps only, which is just a small number, but it still leads to 16 locations that can be reached. So let's read the input, and we will read the width, which will be equal to number of characters on the line, and the number of lines will mean the height of the maze. Now we will make a map which will have this dimensions, and then we will read in the contents of the map by xy. So y is the height and x is the width. That sounds about right. And now we have a const car empty is this, occupied is this, and then we will start calculating the distances that we can reach. So there are actually various ways we can do this, but I think we can just create a method that will give us the number of steps. So calculate reachable, and you will start. Well, this is not what I probably will want to do, but I will do point start position and int of number of steps, or steps, just for simplicity. So we will be this will calculate the number of reachable positions given we are starting at start position and we want to make at most this number of steps. So what can we do here? We can utilize a common queue. So queue, and we queue up the start position, and then we will be counting even steps, or rather we'll have a hash set maybe of visited, and also hash set of reachable, and those will be the steps that are reachable with the number of or even or odd number of steps. So if .2 equals 0, then I will also add the start position, and I also need to, rather, let's do it like this. We will be using a queue with the point and the number of steps we took to reach it. So that's much better. So position, steps, or current steps. Right. So we enqueue position or start position with steps count, or rather 0, because we're starting with 0. And now if steps modulo 2, so the remainder after dividing by 2 is equal to or rather currents, well, get the position from the queue. And if the modularity of the current steps and the target step is the same, so if they are both even or if they are both odd, then we add that into the reachable hash set. Now we have this done, so we can or rather, yeah, that's fine. So we will be only enqueuing the reachable position, so those which are S or dot, and then we will be checking if they will be checking the possible directions that we can take to go forward. So for if current steps is equal to steps, if we reach the end, we continue. And instead of while, we will do queue count as more than 0, because when we're done, then we just return reachable count. So that should be good. And now in here, I will try all the directions that we can go from the current position, and we will use just without diagonals. And we take the new position, we check if it's within the map, and if not, we will skip. And then we check if the new position is empty. One important thing that I want to do here is if input y x equals, let's take these and move them here and do const car start. It's gonna be S, right? It's gonna be capital S. I didn't copy the input. So let's take this one. So it's capital S. So if we find S, we store the starting position. So point start position, and we store it here. XY, and we instead of storing, let me close this. Instead of storing S on the map, we will store empty so that we know it's reachable. So if start position or and then we do sy equals empty. So we use start position as an empty position, so it's easier to walk through the map later. So I kind of override the original state to be empty there. So now we calculate reachable from start position. with initially 16 steps because I wanted to test on the, or rather 6 steps because I want to test on the small example first. So I will do result and console write result. And now we continue here. So with the new position, we check if the new position on the map is empty and it's not already visited, because if we already visited it, we visited it with lower or equal number of steps. So it's no reason to continue because we've already processed it before. So there is no difference in skipping it. And if we visit it, then we, right, I can move this here actually. So we can mark this position as visited position. So initially, and then in here, we enqueue it with the number of steps plus 1, which means that we then continue here. So that should be it, I think. Well, let's try it with the sample input. $16, that seems pretty good. So what I will do is I will take the big input. Then I will not forget to adjust the number of steps to 16. Oh, 64, I mean, and run it again. Right? It's taking longer than I expected. Am I enqueuing too much here? It is possible. Huh. Let's see. Seems like I'm queuing a lot of locations, maybe unnecessarily. Why? Because I'm visited not contains new position, right? So when I enqueue the position, oh, okay, it's possible that I, oh, right. That's important to note. Yeah, so I want to make sure that I add the position here, because otherwise I can enqueue it multiple times in the same person. Or actually, yeah, that's possible. I can enqueue it multiple times and process it multiple times unnecessarily, create multiple branches there. So it's actually better to do it like this and add the start position here. So now it was much faster, and that makes sense. So let's see if this works. And it worked. All right, so that's the first part of this problem done. All right, so let's start with the second one. All right, so for part 2, I will have to preface that I did not know how to solve this properly without getting some hints. So this is a very complex one. I think it's the hardest one so far. The thing is that we are now taking a very large number of steps. So it's actually 26 million steps. And our map is repeating infinitely in every direction. So it's very large. And the number of locations that we can reach is growing very fast as well. So you can see if just 5,000 steps, you can reach 16 million garden plots. So with 26 million steps, the number will be accordingly large as well. So there are several things that you need to notice about the problem, and one of them is that the map itself, it looks like kind of a diamond, and there is completely empty first row, last column, and first column, so you can freely move around the edges of the map. And around the center, which we are starting on, you have empty row and empty column on above and below the S starting point. So this is one important assumption and what's important information that you need to understand from the input. And now, if you imagine it, you can see that the map then is like a grid where, because of this nice property that we just learned, we know that starting from here, we can safely reach somewhere in here with the number of steps that we are given. So the furthest point we can reach is just horizontal by the number of steps that we are taking. The same thing here to the vertical. It's just the number of steps that we are taking, and we can reach this furthest point there, and the same thing there, and the same thing there. So it's like a beautiful cross here, which that means if we are armed with the knowledge that the sides are also empty, that we can then reach some kind of like shape of something like this. Not exactly, but something like this. So the locations, so the squares in between, which are like wrapped in this shape, are fully reachable. So all of these here are fully reachable. And then you have partially reachable squares here and here and here, this one as well, like this one and this one and so on. So always you can see it's like on the diagonal you will be able to reach this guy partially, and then or rather it looks like rather like this. So you can reach this guy, this square, then a corner of this one, and a larger part of this one, and then again like this, then again small corners this one, and so on. So it's like repeating itself. And now now the magic is how to really calculate everything there. So it's gonna be super tricky, and I'm pretty sure I will make some mistakes, so bear with me. I will put the whole solution so far here and now try to do something with this. So our existing method that we have, the calculate reachable, is I've already made it so that we can plug in any starting position and any number of steps. And now the thing is that because the size of the map is, just wait for it to run. So because I didn't put any input there. So let's try this here. So the width and height are the same. So it's actually the same dimension. So map size maybe is better. And that's okay. So that's one of the assumptions. So the map size, the map dimensions are the same. So it's a square. And then, which makes this thing possible. So it means that the shape here will always be the same, and we can rely on this the fact that we will always have this same kind of edge case and larger edge case, and they will repeat along the diagonal. So it's going to be a how do you call it in English? I'm not sure. It's a kosločtverec in Czech language, but I'm not sure what's the name in English right now. So maybe let's see. Translate. Let's see. Rhombus. Okay, rhombus. So it's a rhombus shape, and or a diamond shape, right? And we can rely on that fact. And the first thing that we need to calculate, the one thing that we need to notice here is that map size is an odd number. So if we take one of the maps and we are starting in the middle, so it's 131 is the width. So divided by 2, we get 65.2. But like it means that to reach the edge of this, we will take 65 steps, right? So it's 65 steps, and then 66th step will be an even one when we enter the other map on that's neighboring it. And it's quite important, because if we wanted to reach the center in the other map, it would take us 130. So it's going to be already problems calculating. So 65 steps, 65, so 131 steps to reach this one. So starting the next, while in this one we can reach the even number of steps. So even. Here we will be able to reach the odd numbers instead. So it means that kind of in this checkerboard pattern, there will be there will be maps where we can reach all the locations that will have even number of steps. So this one, and so on. So it's going to be like a checkerboard. And the ones we can reach with odd number of steps. So there's going to be these ones. So what we now want is to figure out how many of these full ones will there be. So that's going to be our first goal. So how many full? So we'll need to calculate the fulls. Then we need to calculate the edges. So there's going to be these edges. So those are the special ones that are at the edge of the rhombus edges. And then third one will be the partials, which will be these on the diagonal. So diagonals. It's gonna be super hard. Okay, right. So let's get started with the full ones. So how many of them will there be? So how can we calculate this number? So this pattern is repeating. So we can imagine that, let's imagine this one is the edge one. So this one would be the edge. So the last one that we can calculate fully is this one. And that would be, it would mean that the number, so we can calculate the distance where we can reach from here. So if it's going to be so square, so it means that this one would be the edge as well, and this one would be the edge, and this one would be the edge. So it means that if we can reach 3, like we can walk 3 steps, 3 maps to the right, 3 partial ones. So it means that full ones, there will be 2 plus, okay, let's do this drawing a little bit. There's definitely some kind of formula for this, but right, this one is no longer theirs because it's like this. So which are contained in that rhombus fully? It's gonna be basically. I will have to probably draw it again because this is getting out of hand. Okay. All right, so we have just a simplified version of this. Okay, right. Okay, it's very simplified. A lot of squares here. So our starting point will be, I drew one more than I wanted, but anyways, this guy is going to be our starting point. And this guy is partially reachable. And this one is fully reachable. Which means if this one is fully reachable, and we can reach the same, we can do the like a turn here, so we can fully reach this one, we can fully reach this one for sure as well, we can fully reach this one, and then we can fully reach this one. I just need to find the formula to calculate the number of those which are fully reachable, so that's what I'm trying to do right now here. So let's draw it. So this one is fully reachable. This one is fully reachable. This one is fully reachable. So like this. Right. That's good. So now we can, if we can go by 1, 2, 3. We can reach 1, 2, 3, then it's gonna be 9 fully reachable with even steps. So if the partially reachable is 3 to the right, then the number will be that number 2 squared, I guess, and the ones which are reachable with odd number of steps will be these ones, which is 4. So it's like -1 squared. So it's just 2 squared, right? And does it make sense? Does it make sense that this is the real number? Yeah, like the number is growing. It's a squared number always, because you have like always diagonally have 2, 1, 2, 3, 4 is going to be growing by 1 always, and we just need to know if the partial reachable one is after even one or an odd one, like this is 0, 1, 2. So if it's on even odd position or even position. So that should be hopefully enough to figure this out. So what I can do, I can do const int total steps, which is going to be the huge number from the input. Now what I can what I can do is I can calculate how far we can get from this position to the right. So it's gonna be farthest right, and it's gonna be the same as farthest top or bottom or farthest. We can do farthest map. So it's gonna be total number of steps divided by, and we remove, subtract the size, map size divided by 2. So it's the number of steps we need to reach the edge here. Then from here we calculate the number of, we want the, oh, let's see what's the number here. If I divide this by map size, and I want to have it as a double, so I can see like how many, what was the number. So the far, okay, so it's divided. Oh, so it's exactly 2023.00. Okay, so I can reach, right? So that means that if I do this, it's gonna be something like 00 and 49.6. Okay. Well, essentially, it seems that we will be able to get to the edge of the last one as well, but we'll not be able to fully calculate. It's going to be like this, like some part of it. But yeah, so it's going to be the number of full ones we can cross is going to be even, or what's it? It's an even number. So even number of this. So the edge one will be filled with even number of steps. So it means that it's going to be math floor. All right, yes, this is very confusing one. So we calculated that we can reach an even number to the right. So this is going to be (2023.00), but that's this one, right? So that's this one. So -1 wait. I need to regroup here. So to reach the edge of the starting map, I need to make map size divided by 2 steps, right? So it's 1, 2, 3. Well, so like, yeah. So that makes sense. So this way, in this moment, I'm on the edge after this number of steps, I'm on the edge of the first map. So now the remaining number of steps is it gives me the number of maps I can reach by dividing by map size. And that number is exactly 2023, right? So this is, 2023, 00. So I can reach exactly the end of this guy, but not further. I cannot get further. So I will be exactly at the end of this one. So -1. So it means that the number of red ones will be three. So if this one is so it's gonna be even one. So right, so three. So this one is even. Means that the one before it is gonna be the black one, so it's gonna be odd steps. So the number of ones with odd will be this number -1. So farthest map. So odd maps, odd full maps. Count will be farthest map is going to be 1, 2. So if this one is 2, so it's going to be farthest map, farthest to the power of 2, and even will be minus that number -1. And is that correct or not? So if it were 2, 3, 4, so if it was 4, the number of black ones would be 1, 2, 3 to the power of 2. No, 4 to the power of 2, right? Because if I can reach this guy, I can reach this one fully, so it means that this one is also part of it. It's so confusing. 2 times 2. It means that it's so if I go 4, it's going to be 4 to the power of 2 and 3 to the power of 2. Yes, that makes sense. So it is hopefully the correct solution, this one. So this is number of maps that I can reach and walk in with odd number of steps, and this one with even number of steps. And now I need to calculate what is the number of steps I can make in those maps, and I can do it odd map step count. It's gonna be calculate reachable from start position with a huge number. We can do 1000, which is like the even numbers, and like this. And even numbers will be like this. Yeah. So if I'm not wrong, which could be the case, but hopefully not. So this is the number of steps you can do in odd maps. This is the number of in even maps. And now this is the number of odd full map count. And that is odd because it should be a long number, because otherwise we will. Let's do u long. Just so we don't. Right. U long. Oh, come on. Okay, long then. Just for simplicity. Long, and now we should not, hopefully, go outside of the range. Yeah, that's good. So we have odd full map count, even full map count, times the number of steps. So odd steps full, odd full map count times this, and this. So this is going to be the number, quite big one, but hopefully we don't okay, I will just for safety, because we did get burned by this before, so I will do checked, and I will wrap this in checked so that we don't accidentally go out of bounds of numbers. Yeah, so this is good. So we have something, and now we need to calculate those edge cases. So what we want is to get these edges, like those small triangles at the edge. We want to start at the bottom left of this, of each of them. I'll calculate how many steps we can make within that square. And just to visualize it, I will get this a little bit cleaned up. So just to visualize it, come on, I will say that this is the extent of my map. So what I can do is I can partially reach this one. I'm here, and the number of steps I can take to get there is this plus this. Right? So it's small triangle top right. It's gonna be steps. It's gonna be total farthest map times -1 times step map size. I mean, no, not map size, but so to get here, I need to get to the edge of this one, so it means half and then full size. So it's map size divided by 2, then times map size farthest map -1, right? But it counts. That includes two. That includes round 4. So it's 3. It's well, if it was 3, then it's gonna be 2 times map size. So half plus 2 times map size to get here. And from here, we need half of the size as well. So it's plus map size divided by 2. Divided by 2 plus one more step to get. So then we are on the edge of this one. So if we go here, then we go here, +1, +1. Right, so we need to make, this is hard one. How do we get here? It's going to be 1 plus half the size +1, so +2 basically, right? So you need to make one more step and one more step to get to the edge, to the corner of that location. So map size +2. 2 additional steps. Is that correct? I hope so. I hope so. Total steps minus this. Let's see what it says. We are left with 328 steps. That's just a little bit too much, I think. So let's see. We seem to be getting too much there because the farthest map is this. I can do, this is the correct one, right? Because we are still too much. Map size is 131. Oh, right. What I'm doing is incorrect. So it's going to be -1. But this is the number of steps we are left with. Which is 64. That's more like it. So we will do small triangle top left. Reachable, small triangle steps. So this is going to be the same for these as well as for these corner ones and these corner ones and these corner ones. So we can reuse it. So small triangle steps and small triangle top left reachable will be calculate reachable new point 0, 0 with small triangle steps. And that's going to be int. Can definitely round it down to int because it's going to be just map size max. And the same thing for top right, top right, this is top right. Top right, top left is going to be map size -1, 0, yeah. Yes. With bottom right is going to be 0, map size -1, and I'm doing it incorrectly. So this is because y starts at 0 at the top, so this is going to be map size -1. This is going to be map size -1. And these are going to be 0 and 0. But it wouldn't make a difference probably, but just so that I'm not doing it incorrectly. Then large triangle steps. So it should be so we reached the center, then the middle, and we are here. Or so if this one is partial, so the easiest point we can reach is here. So it's -2 yeah, okay, so it's -2 times map size plus map size divided by 2 plus 1. Oh, right, plus 2 to reach the corner of this guy. Hopefully. Let's see, what's the number? 260, too much. And I didn't do the same mistake as last time. But it probably is okay. Is it okay? It's 131. Because if I'm here, I should be able to do map size minus map size, and that should give me the same number of steps as this guy, but it's not. So what is wrong there? I get to this position plus half of it plus 1 to this here plus 1 plus half of it plus 1, and this is full map size. So I'm doing something wrong there again. All right, this needs to stay there, of course. This needs to stay there because that's to reach from the center. So it should be this way. Yes, that's better. So this way, we should have the right number. Right. So this is large triangles remaining step. So now we do reachable from large triangle. From this location, top left from -1, bottom right, bottom left. Okay. All right, and now finally how to calculate the number of these that are on the edge. So if the distance is 1, 2, 3. So 4. Let's imagine we can partially reach this one. Then we can, the number of the small corner ones are 1 and 2. And the number of large corner ones is 1, right? So if there is, I can do 2, number of partial ones in the corner for each quadrant is equal to that number of steps that I took. So if I was here, it would be 1, 2, 3 as well. So 1, 2, 3. So all right, so 1, 2, 3 and 1 minus 1. So it's gonna be this is the total number of small triangles on each side, but I need to multiply them by the farthest reachable map count, and the same I need to do with this guy, -1, because the large ones, there will be less of the large ones there. And if everything is correct, I'm not completely convinced about that. Definitely not convinced. So this could be the full result, but we'll see. It's a huge number, but it could be a wrong number. Yeah, too low. Okay, of course. So what could be the wrong calculation here? So small triangles, we have farthest map -1, farthest map, and okay. So evens farthest times farthest is 1. It all makes pretty good sense. And I'm thinking I'm just off by a small margin. What I can try is just take this number and increase it by 1,000. It's still too low. Okay, so it's not completely true that it's off by a small margin. Okay, so let's verify the calculations again. Right, so we have the grid. Here is our starting position. So now to what's the number of how far can we reach in every direction? It's from our position. I need to do, so if the number of the size of the grid is 131, to reach the edge, I need to do 65 steps. And in that moment, I'm standing on the last point within the initial map. So the next step will be into the second map. So if I add the map width again, so it's if I add 131 to 65, I will be standing on this location, right? And can be verified. So yeah, 31 plus 65. Yeah, that makes sense, I think. So if I do, yeah, that's correct. So this calculation should be stable. So if I do, it's 7574, 7612. If I do 17 and like 20, for example, 4 and 612. Okay, so this is okay. Now, the farthest map. We have the total number of steps that we can take. We decrease it by the map size divided by 2. And now divided by map size to calculate which is the edge, the farthest edge that we can reach. And to verify this is really double. I will do okay. Floor it. I will do the check that this number is really exactly 20300. So I can reach the very edge of this map, of this edge case. So starting on even one, I do an even number, I cross even number of maps. So, right, this is the red one. This is black one. 4 is, this is the even one. So dividing total steps by map size minus map size divided by this gives me so if it was just 1, it would mean 2. Okay. It's exactly 202,300, and it's even number, so it looks something like this. Then the number of full red ones is equal to, so this one is full and this one is not full, this one is 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 full, and so on. Like basically it's 4. So if the impartial is 4 distant, 1, 2, 4. So it's 4 by 4 number of full odd ones. That is correct. And the number of even ones is 3 by 3, so -1. And that is correct as well. Yes. Odd step count. Even step count, full map count. Yeah, this seems fine to me. Okay, that seems fine. So I will just remove this change that I did, but this seems fine to me. Okay, so now to reach the last map, I need to cross 3 full maps plus half of the initial map to be here. Then half of the map to get here. Now here, +1 to get here. And that seems to me okay. Is that okay? I think it is. I think it is. So map size plus map size divided by 2 plus map size divided by 2. So this is the distance from the center to the edge. This is the distance. So we first do distance to the edge, then the number of maps that we cross. Then we go to the corner, which is map size divided by 2. And then so it's basically farthest map times map size plus 2 steps to get to the right to the edge, to the corner of that map. That seems to me reasonable. It's always from the same yeah. That seems okay to me. Stop right is 0 map size -1. Map size -1 map size 1 small triangle steps. Top left, bottom right, 0, 0. bottom left, if map size 0. Yeah, that seems all good. If we multiply it by farthest map, because we are starting here. The number of partial ones is 1, 2, 3, 4. So it's, yeah, the number of, for each of those diagonals, it's the number of the distance to the farthest map. So yeah, it makes sense. And for the smaller one, it's going to be 1, 2, 3. So it's for the large triangle, kind of, it's going to be 1, 2, 3. And it's going to be the same on all quadrants as well. So it's -1 times this. So let's verify this number again. Total steps. So we start by going to the edge of the initial map. And we go to the one before. So here. And we make this number of steps, half the map size. So half the map size. Then we need to make 2 more steps to get to the corner of that map, and then we process that. So yeah, large triangle seems okay as well. Map size. We are reaching the corner. Here, we're reaching the corner there. The same thing on the other ones. It all checks out to me. I really confused what could be the problem there. Oh, right, of course. Of course, I'm forgetting the edge cases because as we remember, I made the node here full diagonals. I have covered those, but edges I did not. And that's most likely the problem. I'm not saying for sure, but let's try this. Hopefully it will be the case. So edge top. So it's gonna be edge steps is going to be total. So we go to edge, then farthest map -1 times map size plus just 1 step to get to the first point on the edge of the edge one. Let's confirm. Edge steps is 130. That seems reasonable. And then we calculate the edge top. Edge top reachable, and it's going to be, we will be on its map size divided by 2 plus 1. We're on the center of that, or rather this divided by 2, and map size -1. So this is going to be top. Left one will be -1 divided by 2. Bottom will be divided by 2 and 0. Yes, that's right. And right will be this. So edge steps full will be the total of those. And finally, plus edge steps full, and we'll see. Large number again. We'll see what happens. That's too low still? Okay. Right, now I'm stuck. I thought this would be okay, but it's not. Apparently I'm still missing something. So these numbers seem logical. Map size +1 to get there. And now I need to calculate the number of locations I can make to get anywhere there. This seems pretty reasonable to me. I don't know. This is still too low. Still too low. Let's do this. It will not even tell me anymore if it's higher or lower. Okay. Let me pause the recording. I will go through this once more to verify if I made some mistake there or not. And hopefully I will figure out something. So bear with me. All right, I am back, and I think I finally have the answer to why this doesn't work properly. The reason is, and I kind of mixed up the odd and even maps because the number of steps is not, the total number of steps is not even, it's odd. So the starting map is not an even one, it's an odd one instead of even one. So essentially what we count as odd maps should be even, and the same for the other way around for odd ones. So the number of even maps is this number, and number of odd ones is this number, and that should give us a different result. Hopefully the correct one this time, but it makes sense now. So let's see what happens if I put it here. And that is the correct answer. All right, that was a very, very tough one, at least for me. I guess there is some more efficient, more mathematical solution to this, but whew, this was a tough one. But I'm glad it worked in the end, at least. Finally, we have day 21 solved as well. So there is just 4 more problems to go, and I will definitely push through it somehow. So we'll see each other in the next video, which will be also ChatGPT solving this problem. I'm quite confident that the first part of the problem will be solvable by ChatGPT, but not the second part. I'm pretty sure it will have no chance to solve it, especially because it would have to understand the input format correctly to solve it efficiently. So I don't think there will be a chance for it to solve the second part. But this was a very tough one, very interesting one. I'm happy it's done, and we will see each other in the next video. So Have a good one. Until then, keep coding and see you next time. Bye bye.